All right, welcome back. Another day, another video. Gotta make the Pokemon sound of the day. That Pokemon today is Machoke. Recording this a little late, 8:15 p.m. I had to buy a bicycle today because my last one exploded into a million tiny little pieces. $300 gone. All good. All right, let's take a listen.
Machoke.
It's not sounding too hard. Machoke. All right. Whoops. Reinstall Chrome. It's about to be a... Dude, I don't want to do this, bro. I don't care what kind of vulnerability I got. It'll be fine. All right, car fleet. Or maybe I'll just do this hard one. Even though I have no fucking idea how to do this problem. So let me start off with... I said I was going to start off with the video explanation I remember on this problem. Let me just read it first. I mean, yeah, you just got to get... I know how it works, but... Dynamic programming. What? Alright, let's watch the video. This problem's impossible, guys. It's impossible.
Hey everyone, welcome back, and let's write some more Leetcode today. So it's been a while for me. Sorry, I've been pretty busy, but let's today solve Leetcode 42, trapping rainwater. So we're given...
Bro, I always get this person on my... I watched one video, bro. This person is not insightful, alright? In a nice way, okay? In a nice way. I don't know how they get so many views, bro. I'm just a hater.
An integer array representing the heights of certain elevations or whatever, right? So it's a one-dimensional array.
10K
the
likes,
first
and
value
that's
is
a lot of
0,
likes.
meaning a height of 0, so that's over here. The next value is 1, so that means a height of 1. Some have heights of 2. This one has a height of 2. This one has a height of 3, right? And so given this entire structure, we basically want to know what's the maximum amount of rainwater could this structure trap, right, given an unlimited amount of rain. So you can see this is 1 unit right over here. This is roughly 4 units, right? 1, 2, 3, 4, and then this is another one, right? So when you count all of those, you get a total of 6 squares, right? So the output is 6. This can trap a maximum of 6 blocks of water. So with a picture, it's pretty easy, but how do you know, right? Like, what's the algorithm to determine how much each position could trap, right? Like, for example, this position is the first one, right? So there's no boundary on the left of it, right? So no matter how much water we would add over here, it would all just spill to the left. And the same is true for this position, right? No matter how much water we put on top of here, even though there's a right boundary over here, right, there's nothing on the left of it. So all the water is just going to spill out to the left, so it's not going to trap any water. But you can see in the third position, we are able to trap exactly 1 block of water. So what's the algorithm to determine why is it 1, right? Because we care about the height, because we want to know how much water. And it's actually pretty simple, right? Take a look. So here we have 1 block of water. What if I added a second block of water? Well, we can see that there is a boundary on the right. This is good, right? But what about the left side? There's no boundary over here, right? Meaning any water I add is just going to spill out. The boundary only has a height of 1. So we're seeing that the height on the left is 1, the height on the right is 2. So we need to take the minimum of that. We need to take the minimum of 1 and 2 because that is our bottleneck. That is what's determining exactly how much water we are able to trap per position, right? For every single position, we need the max height on the left and the max height on the right, left and right, and then we need to take the minimum of those two. Let's take a look at this position. Clearly we can't trap any water here, but why exactly is that the case? Well, when you look at the right position, right, in the entire right section, the maximum height is a 3, right? So that's good. 3 here. What's the maximum height on the left side? It's a 1, right? This position is a 2. If we take the minimum of
Can I take...
I'm
just going to let him finish.
1. So that's our boundary. That doesn't mean we can trap any water here. We can trap 0 water here. The reason is because the actual calculation is we're going to take the minimum. We're going to take the minimum of the maximum left height and the maximum right height. We're going to take the minimum of those two. And we're going to take the height that we're currently at, right? So let's
subtract current height.
H of the index I that we're at. So this is the equation we're going to use to determine at every single position I, let's say this is our I position, right? So you can see I is...
Wait, this is just a DP problem. Hold on, let me cook up the DP solution. Let me cook it up. Trap. So we're going to want 2 vectors, I think. Yeah, so vector of ints left, initialize vector of size C++, my vector size, okay. And then right size, and I can put a value here. So if I do like 0, yeah, so then I would do 4 int 8. No, I want to do size underscore t I. Oh, it's I1 height. Because then I would go here and I would do left at spot I is equal to the max of height at spot I minus 1 and left at spot I. I don't know, guys. No, this one should be 1. Oh, it's height at spot I. Okay, and then now I need to do this same thing, but for, okay, so for size underscore t, I is equal to height dot size minus 1. I is greater or equal to 0. I minus minus. Right at spot I is equal to the max of height. Should this be minus 2? Max at spot. right at spot I. Okay, so I'm pretty sure that's right. And then I'm gonna have a int res equals 0. And basically for size. Res plus equals the min of left at spot I, right at spot I, minus height at spot L. And I can only do this if this is above 1. So if is greater than 0, oh, what is L? It's I. Oops. Bruh, overflowed? Let me just make sure. Char runtime error, addition of unsigned offset to overflow. Wait, but I want it to go to 0. Yeah, that's not true. It should be 3. What? What if this was an int? Okay, so it's definitely not size T for that. Okay, I don't know what the hell size T is for then. I really thought that's what it was for. All right, let's see if this works. Hmm. Well, that's not right anyway. Oh yeah, it is 0, 0, 1, 0, 1, 2, 1, 0, 1. That's right. Why is this one not right? Like this should have been 1. I think. But it's not 1. That's not cool. How is it 2 though? Like what? There's space right here. There's space right here. Wait, this should be 4. This shouldn't be 2. This should be 4. That's the problem. And this should... Wait. This should be... This should be 5. Do I not have this set up correctly? Is it -1? Are they both -1? That doesn't seem right. So that means these are both +1? Oh, maybe I got it. I mean, this is not the 2-pointers solution at all, so, but let's see. Nice. Nice, nice, nice. Okay. Honestly, that's good enough for me. I don't want to do this problem anymore. Let's do one more. I don't want to do that one. I'll do it later. We can do a sliding window, linked list, or binary search problem. Let's do a binary search problem. Okay, well, like, man, this problem is really hard, I remember. Like, okay. Um, I think that's right. But then that happens. I don't know. It's weird. Okay. Char addition of... How? What? That still doesn't make sense. Okay, but this algorithm is correct. It's just the size T. Like, what the hell's the... Dude, I don't even think this guy knows. Is generally good practice. Oh, that's why you... Wait, avoid overflow. Weird. Very weird. Okay. All right, let's do like one more like easier one, and then I'll do some harder ones tomorrow. Because I did that. This trapping rainwater was supposed to be like way harder. Let's do a sliding window. Yeah, so I need a dictionary. Unordered. Unordered map of char int. Size underscore TL 0. Okay. Basically, we'll do okay. Char C is equal to S at spot R. Can I do that? I hope I can. Yes, you can do if R is an STD string. Okay. If while do I first try this code right here, guys? Take your guesses. Take your guess. First try check. First try check. No matching function. Man, you guys are killing me, bro. What do you mean? What do you mean no matching function call? Oh, because these are... You're supposed to do this before. There you go. And we stay sliding the windows. Okay. I can be happy with that. Let's move on to some learning on some learncpp.com. You know, we love to see it. Let me refresh this whole thing. take a look-see what we got going on here. So we're gonna do this for the next probably hour. I don't know. What's a literal constant? Constant was I turn my heater. It's cold. I'm freezing. I'm freezing. Okay. Why is this an oxymoron? Although it is a well-known oxymoron, a variable whose value cannot be changed. Oh, because variable is like, it means changing. Like account for a variable means account for something you don't know. That's funny. That's very funny, guys. Are you laughing? I hope you guys are dying of laughter. Yeah, I know about that. Cons before, I knew about that. Okay. I don't know that. Know that the cost variables can be initialized from other variables. Oh yeah, I just read that. Um, naming. Let's do a note. intercapped names with a K prefix. Nice. Very neat. Yeah, I knew about that. We don't. Okay, that's interesting. All right, generally. Don't use const for value parameters. Got it. We'll talk about two other ways. Proper use. That makes sense. Okay. What does that even mean? Don't use const when returning by value. Ignored. Okay. Gods of spelling. Okay. Hmm. Avogadro's number. As of C++23, C++ only has two type qualifiers, const and volatile. The volatile qualifier is used to tell the compiler that an object may What does CV stand for? The joke is that the CV qualifier is the thing at the start and a CV is a resume. Very funny. Very funny. Hilarious even. Died of laughing. Laughter? Died of laughter. Literals are values that are inserted directly into the code. Ugh. Literals are often Nice. Oh, that's neat. Like I'm going a little slower today, but that's okay. What? In such cases, the compiler will convert the int. Hold on, I gotta set up for this. In the first case, 5 is already an int by default, so the compiler can use this value directly. Okay. Sure. Oh, and that's what that means? Okay. Can you not? Is it double literal? Oh. Interesting. Very interesting. There are two ways to write floating point literals. In standard notation, we write a number with decimal. In standard note, in scientific, we add an e to represent the exponent. Okay, that didn't teach me anything. Yeah. String literal. Yeah, I already knew that. Yeah. Yeah. Unlike most other C style. Really? The fact will become important. Okay. Sure. I don't know what string view is. I'm not entirely sure what that means. I'm not going to go further. I don't really know what that means. I'm just going to leave that bullet point there. Yeah, I know about magic numbers. Hmm. That makes sense. The name of the constant provides context, and we only need to update a value in one place to make a change. All right, take a break. We're back.